Okay, I'm going to talk about estimates. So let's estimate the value of the y equals 2 to the x function. I should have labeled this. Value of y equals 2 to the x function when x equals 1/2. So here we have 1/2. Well, the point on the curve corresponding to 1/2 is here. We can find the y-coordinate just by projecting over to the y-axis. Now we see the interval between 1 and 2, between y equals 1 and y equals 2, and we see that this point, this y-coordinate, lies not quite halfway between 1 and 2. So this y-coordinate is 2 to the 1/2. Let me use this color here. Okay. This color contrasts a little bit. Okay. 2 to the 1/2. Is represented by this coordinate on your y-axis. Now, it's clearly not quite halfway between here and here. As a matter of fact, if I made a straight line between here and here and went up to that straight line, then the y-coordinate would be halfway between 1 and 2. It would be 1.5. Okay, 2 to the 1/2 is clearly less than 1.5. Okay, because of the concavity of this graph, it lies a little bit below the halfway point between 1 and 2. So we estimate, I want to draw a little bigger picture of that. So here's this point, here's this point, and here's the curve. And here's the y-axis. Here's y equals 2. Here's y equals 1. Here's the point we're talking about, halfway between. We project over to the y-axis. Here's our 2 to the 1/2. If I was to draw a straight line connecting these points, then the point that I get here would be where y equals 1.5. This point is clearly lower than the y equals 1.5 point. Now, that graph is a bit distorted. I've got too much concavity in it and so forth, but it's to illustrate the fact that 2 to the 1/2 is not going to be quite 1.5. It's going to be a little less than that. You could reasonably estimate 1.3 or 1.4. Okay? Could be 1.3 or 1.4. If you've got a well-drawn graph, one of these will clearly be the better choice than the other, but I'm going to leave that for people to think about. Okay, in any case, I could estimate the y-coordinate for any x-coordinate that I can reasonably locate on the graph. If I want to estimate the value of 2 to the 1.3 power, well, here's 1. So here's the 1.5. So 1.3 would be about here. So here's x equals 1.3. I project this point up to the graph and project that over here. And then I'll go ahead and subdivide the interval between 2 and 4. Divide that in half, and I've got 3. So I see it's between 2 and 3, and it's a little less than halfway between 2 and 3. So I could say, okay, 2 to the 1.3 equals 2.3 or 2.4. Put a question mark before that and after that. Of course, you go to your calculator and do 2 to the 1.3 power. You probably come out with something close to 2.3 or 2.4. But you should reconcile that with your estimates. You should have a graph that's accurate enough to make these estimates to within 1/10 and to locate points here reasonably within 1/10 of a unit. Then you have a good graph. You can use it as a basis for deeper understanding of these functions.